This one, they actually tell us both of dxdt and dydt, and I'm going to take into account my initial position here. Just make sure I got all that stuff situated there. Letter A is talking about horizontal movement. So they're talking about the x's. Is that going to the right or to the left? So what you want to do is figure out dx dt at that x equals 2. And if you get a positive number, it's going to the right. If you get a negative number, it's going to the left. So all you got to do is take the 2 and plug it in place for the t, and for the dx dt. That's a positive number. So that means the particle is moving to the right. And then just stress moving to the right since that dx dt is positive. And then they say, find the slope of the path. Now, when you see slope, that's always dy dx. On the parametric one, the basic formula, dy dx is the same thing as dy dt over dx dt. And then they want at x equals 2. And so we already know the dy dt and dx dt. So we're just taking that 2 and plugging in for those t's into both of those functions right there, and then just plugging that into the calculator. So part A done. Part B, anytime you want to figure out the position, you got to always take into account that initial position. So if you want to find the x coordinate at t equals 4, that's like x of 4. And then the initial position at t equals 2, you already know where you're at t equals 2. So your x position is 1. If they're talking about find the y coordinate, then our initial y value would have been 5. But see, when you want to find the position at t equals 4, start with what you're given. Your given initial position is at t equals 2. So if you already know where you're at after 2 seconds or 2 minutes or whatever, then you want to just start with that and then pick it up where you left off. And then when you integrate that dxdt, that tells you how far your x's have gone in between the 2 and the 4 seconds right there. So initial position, pick it up where you left off, go to where you want to go, integrate the dxdt, you know that's going to give you the position of those x's right there. And then then that's a math 9 problem, combine those, and then you're going to get that. Letter C and letter D, 2 formulas that I gave you in the notes for those extra video lectures there. The speed is just the square root of dx dt squared plus dy dt squared. And when you do the total distance traveled, that's like that arc length formula that I gave you, the total distance traveled formula. That's just the integral of that dx dt squared plus dy dt squared. So all of these are just calculated problems. So the speed, you just plugged it into, you just plugged that 2. I just plugged I'm sorry, it says that t equals 4 for letter C. So I took the 4, I plugged it in for all those t's, and I just got those numbers right there. Now, when you get the acceleration vector, we know the acceleration vector is just the second derivative at 4. So if you have the first derivative, if I'm on the non-calculated part of the test, I would have to take those derivatives separately by myself and plug in the 4. But since I'm on the calculated part of the test, I can use the Math 8 feature. And so I already have those entered in there. You can watch that graphing calculator video to refresh how to actually do this. But if you just hit Math 8 with that x equation at x equals 4, there's how I typed that in case you're wondering. And there's how I got that negative 0.041 number. And then if I hit the Math 8 button again, and then this time I plugged in that dy dt, so you plug in that dy dt, it'll take the derivative of that for you at x equals 4 and give us that second derivative, right? So that's how you type that stuff into the calculator. And then for letter D, as long as you know that formula, it's a pretty easy problem. And then you had to take those 2 equations and plug those in place for the dx dt and dy dt squared. So I'm going to hit the Math 9 button on my calculator, and I got that entered in here for you already. So this was a little bit of a lengthier one. So if I hit enter on that, and then I'm just going to scroll so you can kind of see if you mess some up, you can kind of double check yourself there. But I have a giant square root in there. I did the Math 9 integral from 2 to 4, a giant square root. And then I actually put this in parentheses. It's just not showing it because it's already connected. But I put that dx dt in parentheses and then squared. I don't know why it's not showing that. And then when that sine squared was being squared, I knew that was the same thing as the whole sine of function being raised to the 4th. There's my dx dt squared plus a dy dt squared. And then I got that dx right there. And again, when I entered that in, I put that dx dt in parentheses and squared it. And then when it simplified, it just kind of looked like this. But then notice when you hit enter on that, that's when you're going to get that 0.651 number that I got for the answer right there. So you always need to show your setup so they know you're using your calculators for these things, but your brain is coming up with those formulas and those setups and those numbers there. So you always have to show the work there. It's not a lot of work that you got to show, but you got to show that setup and then go to the calculator. So please write stuff down because you can get some partial credit on some of these problems there. Windy and cloudy.